All right, so this next problem has us doing a tree diagram. So what is a tree diagram? Basically, it's a way to figure out the number of combined choices, and it looks like a tree when you get done kind of sideways. And so it says a company offers its employees health plans from three different companies, R, S, and T. Now, each company offers two levels of coverage, A and B, with one level requiring additional employee contributions. What are the combined choices, and how many choices are there? Solve using a tree diagram. All right, so with this, basically what we're going to do is we're going to have a starting point and an ending point. And so let's say, there it is. We're going to start over here, and we have three choices for companies. We have R, we have S, and we have T. Now, each of those offers two levels of coverage, A and B. And what they want us to do is figure out how many choices there are and what the combined choices are. So these are basically our ending points. So this is ending. So these are the company. This is their coverage. And our combined choices are going to be what? Well, it's going to be R then A. Then we have R then B. And then we'll have S then A. And we'll have S then B. Then we'll have T then A. Oops. And then we'll have T then B. Okay. So how many choices are there? There's going to be one, two, three, four, five, six choices. And these are the combination or how they work. RA, RB, SA, SB, TA, TB. Okay. So that's how a tree looks. And if you look at it, it kind of branches off, and that's what it all is about, branching here. And so we could have had after that the coverage, this one costs so much for this, and this one's so much for this. So you can actually have a lot of branches of each one of these. And so this could keep going and going and going. And it grows and gets fairly big. So sometimes that can get very complicated. And so what we're going to do now is we're going to look at the multiplication principle for counting. Now, if we have two operations, O1 and O2, for example, they're performed in order with N1 possible outcomes for the first operation and N2 possible outcomes for the second operation. Then there's going to be N1 times N2 possible combined outcomes of the first operation followed by the second. Now, in general, if they're in operation, so say we have O1 through ON are performed in order with possible number of outcomes of N1 through NN, respectively, then the total number of outcomes is going to be N1 times N2 times N3 all the way up to N times N sub N, and that's going to be the number of operations performed in that given order. So, with this one, what does that mean? Well, each question on a multiple choice test has five choices. If there are five such questions on a test, how many different responses are possible if only one choice is marked for each question? All right, so if we have five choice test, we have five possible there. Now, in each one of those, there's going to be what? There's going to be five possible ways to choose each answer, right? So we have five possible ways here. There's going to be five possible ways here, five possible ways here, five possible ways there, and five possible ways there. And that's going to be what? 5 to the fifth. And if we multiply that out, that's 3,125 possible one choice answers because there's five ways to do this one, five, 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 and five. And so this is kind of called pigeonholing because we're saying, okay, well, only so many can go in each one of these, and how does that work? And we'll see that in the next example when we have some different code words, things like that. But that's how we're going to do it. We're going to make kind of underline things, and we're going to say, okay, well, this is how many choices can go in each possible way.